Let's look at some rules for the mean and standard deviation of sampling distributions of x bar. Suppose that x bar is the mean of an SRS of size n drawn from a large population with a mean mu and a standard deviation of sigma. Then the mean of the sampling distribution of x bar is equal to the mean of the population distribution. The standard deviation of the sampling distribution is equal to standard deviation of a single item divided by the square root of n, so it's actually smaller. As long as it fits a 10% condition, remember, there it is. This behavior is in repeated samples is much like that of the sample proportion of p hat. The sample mean is an unbiased estimator, meaning x bar, the mean of x bar is real close to the mean of the population. The values of x bar are less spread out. By how much? Well, by the square root of n. You should use the formula standard deviation divided by the square root of n for standard deviation only when it fits the 10% condition. Now when the population distribution is normal, then the sampling distribution is also going to be normal no matter what. As long as it fits the 10% condition, you can use this as standard deviation. That's pretty simple. The central limit theorem comes to the rescue when we do not have a normal population distribution, since that's what we want. We want our distributions to be normal. But the central limit theorem states that if you draw an SRS of size n from any population with a mean mu and a finite standard deviation, the central limits theorem states that when n is large, the sampling distribution of the sample mean is approximately normal. That's going to be a big deal for us. So if the population distribution is normal, so is the sample distribution, no matter what the size of n is. So we're easy there. If the population distribution is not normal, the central limit theorem tells us that the sampling distribution of x bar will be approximately normal in most cases if the sample size is greater than or equal to 30. Now remember, sampling distribution is a distribution of samples. There's a sampling distribution of a bunch of x bars. In other words, it's a distribution of sample means. All these x bars have the same number of items in it. Sampling distribution of sample proportions is a distribution of proportions. All these proportions have the same number of items in them too. That's the sampling distribution. See, with a little work, we can make pretty much anything normal. Even that.